Generative AI isn't just about crafting photorealistic deepfakes or novel art. It's fundamentally about mastering the ghost of data itself. Unlike discriminative models that classify or predict based on learned boundaries, generative models reconstruct an entire probability distribution, learning the infinite variations and subtle relationships that define a dataset. This deep understanding allows them to sample from this learned distribution, producing entirely new yet statistically consistent data points. Consider the latent space, a low-dimensional embedding where the model encodes the most salient features of the data. By disentangling these latent dimensions, we gain fine-grained control. Imagine smoothly transitioning between distinct styles in an image or incrementally adjusting a molecular structure to optimize a property, all without explicit feature engineering. This capability unlocks transformative applications far beyond artistic endeavors. Think data augmentation in domains with scarce or sensitive information like medical imaging, where generating thousands of synthetic yet clinically plausible MRI scans can dramatically improve diagnostic model robustness. Or in drug discovery, synthesizing novel molecular compounds with targeted properties accelerating research cycles. Traditional data synthesis often relies on explicit rules or simple statistical perturbations, methods that struggle with high-dimensional nonlinear dependencies. Generative models, particularly variational autoencoders or generative adversarial networks, implicitly learn these complex hierarchies, capturing nuances that rule-based systems simply cannot. However, challenges persist. Mode collapse, for instance, is a critical limitation where a generative model fixates on a narrow subset of the data distribution, failing to capture its full diversity. Evaluating the fidelity and diversity of generated outputs remains an active research area, often requiring subjective assessment or complex metrics. Ultimately, generative AI transforms data creation from a deterministic act into a probabilistic exploration, revealing not just what is but what could be hidden within the latent dimensions of our information. It empowers us to query the very essence of data, pushing the boundaries of what is synthesizable and discoverable through code.